introduction. So I want to introduce our next speaker, Dr. Mike Becich. I have known Mike for many, many years. He introduced me to pathology informatics, and I think in many ways, some would regard him and Bruce Friedman as forefathers of pathology informatics. You know, they founded conferences and groups and consortiums and many, many things. I have learned a lot from Mike over the years as a colleague, as a mentor. So I'm really pleased that he's actually was again able to make time to attend this workshop, give us insights. So Dr. Becich is the Associate Vice Chancellor for Informatics and Health Sciences. And at University of Pittsburgh, he is the founding chair of the Department of Biomedical Informatics. And he leads the department's efforts to use technologies to advance biomedical research and clinical care. And he's a GU pathologist and an excellent GU pathologist. The scope of his department's research ranges from genomics and proteomics data mining to machine learning and biosurveillance. And he has grown this from a center to a department with extensive funding from multiple sources. So his personal research is focused on clinical informatics and the interface between bioinformatics, and has studied clinical phenotyping of patients of personalized medicine, tissue banking informatics, and pathology informatics, and data sharing. He's the current fellow of American College of Medical Informatics. He is the founding president of the Pathology Informatics Association. And through his efforts over many, many years, many medical students, high school students, in fact, my own daughter benefited from one of the programs that Mike put together, has trained extensive number of trainees in pathology and in biomedical informatics. So I'm really very, very pleased to have him speak at our conference. He's going to talk about how computational pathology is improving predictive analytics. So Mike, you have the floor. And you can share the screen.
Yep, sorry. Rearranging screens so that the 90 windows I have open can be appropriately shared. So hold on a minute here. All right, does everybody see the appropriate screen now?
We do, yes.
All right, well, first of all, oops, I'm at the end of the talk instead of the beginning. So let me go all the way back. Try it again here. All right, let me reshare. All right. Having difficulties with.
I think it works. We are on the first slide. Everything is looking good.
All right. It's not showing it that way on my side. I just want to make sure I got this right. Sorry.
So the first slide we see is your family on.
Now I see your lovely family on their desktop.
All right. Well, I'm getting there. Just be patient for a second here. Boy, this multi-screen setup is not behaving today. Let me try again. I don't know why it's giving me this difficulty, but we'll get us there. You see the first slide now?
Not yet.
How about now?
Yes.
All right. So unfortunately, since some of you will be seeing my video, I'm in grant writing mode. That means I'm wearing a baseball hat and a scrub top and not dressed for the occasion. So I'll apologize for that. So with that initial apology, I appreciate the effort of this team to put together this series. And I will give you a disclaimer to begin with that I'm not quite prepared to understand who the audience is for this, but after this initial kickoff, if you do invite me back, I'll be better prepared to kind of target the talk to the audience. So I'm going to use a talk I gave quite some time ago at the NCI as a starting point and use it to kind of hop off into topics that have already come up in the chat, if that's all right with the team here. So with that, like always, I have to start with disclosures. I am involved in several startup companies, some of which will be discussed in the talk that are highlighted in blue, including DID Data Corporation, a company that de-identifies with software medical text, a company by the name of Nexi, which was launched by Rebecca Jacobson, now formerly Rebecca Crowley, to which royalties accrue to my department, and a current effort with significant conflict of interest in this talk, Spintelix, which is a new spatial intelligence for cancer diagnostics, and I have founder equity in it. And the rest of the disclosures here are numerous consultancies I do in cancer centers and CTSA programs and in biomedical informatics consulting, and of course, the federal grants that support this work. And finally, I'm a member of NCI's Board of Scientific Advisors. What's the message in this slide? No conflict, no interest. So I'm as about a conflicted as you get, but I also am very interested and energized by where this discipline is going. And I encourage all of you on the seminar to get a slide like this as well. So some of the take-home messages of this are pretty basic about computational pathology and what's driving it. What my role as an informatics leader and a pathology informatics leader can bring to the table for computational pathology and predictive analytics, and what we're still doing in Pittsburgh to support computational pathology and its growth. How important it is to look at the intersection of both computational pathology and computational radiology, or pathomics and radiomics, or pathogenomics and radiogenomics, and how to enable those partnerships, and what predictive analytics for health and discovery science can be accomplished via ComPath. So think about these slides merely as some hanging points to stimulate discussion. I hope to finish early and dialogue with the audience. So you all know about whole slide imaging. If you don't, there are workflows that relate to traditional slide processing and diagnostics, and how for decades now our team has really worked hard to reform the workflows to enable the amazing work that Yul just presented to you in the framework of new infrastructure that pathology departments should support, at least modern pathology departments should support. Interestingly, this is from an article by Bertram and Kopfleisch in Veterinary Pathology of 2017. I will hold to you that veterinary pathologists are more challenged than human pathologists and should be our partners in this group, and we should reach out to them in partnership, because in ways they may be driving key parts of the discipline's adoption of whole slide imaging, but we have to pay more attention to them as we move forward. So this is really a sentinel event in whole slide imaging, the FDA approval of whole slide imaging. I won't talk a lot about this. I see that there are others that may cover this, but in 2017, the first whole slide imaging system was approved. This is from an article and a presentation by Laron Pantanowitz, who's now the director of anatomic pathology in Yul's department at Michigan, formerly at the University of Pittsburgh, and formerly a partner with Laron and I in our march to establish whole slide imaging and its adoption throughout pathology. So what is computational pathology? It's where big data science meets pathology. there are massive increases in the volume of digital data being generated in individual departments and laboratories, and this heralds the rise of computational pathology. Tom Fuchs, as you know, at Memorial Sloan Kettering, has really been a champion for computer vision in computational pathology and its data sets. These are a couple of images from one of his previous talks. And essentially, computational pathology is critical for personalized medicine, learning health systems, basic research, and big data science and pathology. And pathologists must understand this opportunity and rise to the challenge in their practice as they implement whole slide imaging for clinical practice. And, you know, it's big data. This is from an article of Joel Saltz, a longtime associate of mine, circa 2011, about where we are with various activities, including whole slide imaging challenges that are out there. So lots going on in this discipline, and a lot of data is being generated. It's up to us as stewards of this data to make sure this data is available not only for improving pathology practice, but also improving basic research like Ewell's in this discipline. So a definition of computational pathology is an approach that the diagnosis that incorporates not just whole slide imaging, but multiple sources of data that pathology is responsible for, making that data clinically actionable or taking big data to knowledge, and then advancing decision support for precision medicine to personalize care through this. And this really means that pathology has to go from an observational discipline to a knowledge engineering discipline. This is from a very important article done by David Lewis and his colleagues at Mass General in Archives in Path and Lab Medicine in 2014. I'd hold it that MCCP should probably create a nice repository of publications in this space for its membership, and I'm happy to help with that as I have appropriate infrastructure to help do that. On the other hand, in this big data world we live in, you can get to these articles, but organizing an advanced reading list for this group is probably one of the things we should think about doing. So as Ewell very eloquently stated, as well as the introductory speaker, data types will be critical to the success of predictive analytics, and it's not just imaging. It's phenotype data from the Anatomic Pathology Lab Information System, both structured and unstructured data. It's also data from the electronic health record, as well as from important aligned systems in cancer diagnosis, like the cancer registry. And the data to integrate is really challenging because it's in biobanks, it's in clinical pathology, it's in molecular pathology, it's in anatomic pathology. And how do you put all this data together to essentially rise to the occasion as knowledge engineers in pathology to help both diagnostics and discovery biology? So I've left my role as a practicing pathologist to chair a basic science department in the medical school in biomedical informatics, and really emphasize it's important to have a research data warehouse and a robust biorepository supported by key aspects of informatics science to enable this. You've got to have database design and query. You've got to have natural language processing. You have to be respectful for vocabularies and ontology. You have to de-identify this data for use by researchers, and then finally implement. And our flavor of machine learning at Pittsburgh is very Bayesian focused, particularly causal modeling and discovery. And we are very actively accruing grants and programs nationally, like the Precision Medicine Initiative, or the All of Us program, the PCORI Clinical Data Research Network, the CTSA program, which requires a research data warehouse, and aligned NCI programs. Some of the old ones that we were funded on are listed here, as well as common fund programs to enable this march for computational pathology. And in the past, our team, led by Rebecca Jacobson, had an effort that was funded by the NCI ICTR program, the Information Technology for Cancer Research program called TIES. Unfortunately, this program was sadly defunded, but was an effort that we put together to kind of accomplish this. And we're proposing a combination of both pathology and radiology documents co-managed by such a system and have a track record in this space. But I won't talk about it today because we're not funded to continue this work. A great idea that unfortunately NCI did not feel was worthy of continuing. The paper that describes this infrastructure that's listed here by Rebecca Jacobson is available, and I can post it on the chat box if folks are interested in receiving it. So what our Pitt Center for Causal Modeling and Discovery did is combine the TCGA data sets with imaging data sets. And again, unfortunately, this program was funded for 4 years and is now defunded. We are using our CTSI and precision medicine initiatives to carry this work forward. But the driving biological problems that this Discovery Center aims are still out there, and that's taking genomic data, particularly single cell genomic data, and combining it with radiology data to meet the needs both of computational pathology and computational radiology. So stay posted. The next version of the work we're doing in Pittsburgh, I can present in future workshops down the road. An example of what computational pathology fueled by causal network discovery can do is this paper from Cell in 2010, in which genes that are aberrant in melanoma can be discovered on probabilistic networks and uncover genetic drivers that can then be tuned to precision therapy. So what is it that computational pathology in this infrastructure really is trying to solve? It's this problem. You know, a human can probably take 5 to 10 bits of data and look at them and remember them in deep enough integrity to make decisions about them. But today we're dealing with hundreds to thousands of facts for every decision we make in pathology. And computational pathology algorithms, like those that Anant is going to discuss in a second, and Yule is already fueling with his NIDDK initiative, really are tuned to help humans and their limited cognitive ability to do more via artificial intelligence. This is from Bill Stead in a 2009 presentation heralding the rise of AI in medicine. And you know, we are simply overwhelmed with data these days and need computers and AI algorithms to help us be better pathologists using all the data at hand and not just the 5 to 10 items we can keep in our cognitive grasp. I thought one of the jumping off points I could make would be to talk about some of the problems in biology that are driving the use of AI via computational pathology. And one is intra-tumoral spatial heterogeneity. These tools, like the ones that Yule has talked about, single cell genomics and codecs and other forms that essentially start to dissect the cells that are involved in cancer, are an important thing we have to focus on as pathologists as we evolve our practice. Quantifying that heterogeneity for diagnostics, prognostics, and immunotherapy is another thing we need to do a better job at, and are starting to scratch the surface with both the Human Tumor Atlas Network efforts that I posted in the chat box and HubMap, which is another effort focusing on dissecting cellular programmed genomics to morphology and dancing between the two with great fidelity. One of the things we as pathologists have to get busy on is, although the H&E is our primary way of working, the integration of multi to hyperplexed immunofluorescence data is really a critical next step in our evolution as pathologists. There's a lot of activity in this space, and I'd advocate to you, if you don't know about what's happening in this space, follow it closely, because it's coming to a pathology diagnostic cockpit to you soon, at least if I have anything to do with it. Histopatholomics, then, spatial integration that addresses tumor heterogeneity and also brings to light H&E and multiplexed imaging, along with proteomics, genomics, epigenomics, multimetabolomics, are things that are in our horizon. And I do believe that this is a promising space to empower pathologists as precision diagnosticians for patients with cancer and other inflammatory diseases. Yul nicely outlined how ground truth and annotation is going to be critical. There's a lot of activity in this space. This is where practicing pathologists working with computational pathologists could make a big difference. And I advocate for more pathologists to get involved in these levels of annotation and automation to improve our practice. Having callable histologic features that are automated for the pathologist is one of the focuses of my company, Spintelix. To essentially automatedly identify and stratify by importance on the diagnostic problem at hand through callable ID features with automated annotation is part of the good work of Spintelix. Triaging these ROIs based on most suspicious, the least suspicious, will make whole slide imaging systems more efficient for their use by practicing pathologists, and it is the goal of our Histomapper tool in Spintelix. Computational pathology and AI, they're hand in hand going to change the way we think about our practice, and I'm glad to see this workshop addressing this in this section of the workshop. And the goal's got to be to decrease our error over time by the use of human and computers working in concert through AI with validated instruments. And the team should also focus on how the FDA can improve our path to getting these tools in place as we move forward. So I can't emphasize enough that pathology and radiology as diagnostic disciplines have to partner. This convergence of radiomics and pathomics is an important part. I know Anant Matabushi is very focused on this area, and I applaud his work. Tom Fuchs at MSK, now at Mount Sinai School of Medicine, is also focused in this area, as is his company. And I do think a lot of innovation is going to come in this space as we move forward. So with that, I'll take time for questions. You can email me at becich@put.edu, and I apologize for my significant conflict of interest portrayals of my own company. But you know, true translation is taking research ideas and putting into practice into the hands of thousands, if not hundreds of thousands of individuals. And that's what these efforts, led by the Association for Pathology Informatics, please join, publish in the Journal of Pathology Informatics, which Anil is a co-author with Laurent. You can see how these meetings like MCCP can lead to really amazing infrastructure. And finally, I just want to thank the Spintelix team. This is when they were at the University of Pittsburgh, and now a good portion of these are in the company. I wish you luck with your own efforts. And I want to make a plug for our dying computational pathology interest group at Pittsburgh. I'm looking for a leader to step up, perhaps through this consortium, to continue the work on this lecture series. And if you want to volunteer to help us re-enliven this at Pittsburgh, I'm happy to take suggestions. Now that Chakra is CEO of our company and Barak is the lead technical officer. So with that, I'll take questions. I haven't been monitoring the chat while I'm giving the talk. I'll take a look at that now. So you can either drop questions in the chat or ask me directly. Stunned silence.
Any questions for Dr. Becich? So, Mike, thank you so much for your insights. And again, I'm going to ask you the same question, like from your perspective as a pathologist, and also now the chair of biomedical informatics in Pittsburgh, and you know, starting many different efforts, and you know, actually building one of the first commercial whole slide scanner as an endoscope. How do you see this convergence happening more fluently? You know, like our goal for this workshop is to bring, like computer scientists together with pathologists. How do you see that happening more fluently in terms of needs for the, if you look at an average pathology department, if you look at their workstations, if you look at the, like things that they have at their disposal, do you think they can honestly and realistically use some of the tools that, you described or others have built happening in a day-to-day operation?
So Neil, it's 1, 2, 3. The one is we got to train our pathologists to respect and understand the value of data sharing as part of their practice. I think that honestly is the biggest problem. The tortured history we had at Pittsburgh of getting to true data sharing setup. But under Rajiv's leadership as anatomic pathology director, I think we're going to make stunning success moving forward now that he and I are aligned in thought, and some of the barriers to doing that are now removed. So first is pathologists who understand the importance of data sharing as part of their job. The second part of that is a really dynamic partnership with industry so that fluidly information can flow to and from companies, particularly startups, as part of that infrastructure. And, one of the crazy roles I've taken on at Pittsburgh is to run a Center of Commercial Applications of Healthcare Data. We're in the end of our 6th year and currently negotiating for another 6 years of funding. Spintelix, the company I'm involved in, came out of that effort, the Center for Commercial Applications. So I'm very proud of that. On the other hand, because of the chokehold on data, my own company has had to go on to private practice groups and outside of the University of Pittsburgh, where this should be happening, to make this happen. The universities that stand up a fluid flow of data to companies, and obviously, I don't know if Tom in the audience today, he could perhaps comment on his tortured history at Memorial Sloan Kettering. But, I think what they did at MSK is very notable. Now, did they do it the right way? Could they have done it better? But I do think as a model, MSK's just signing up the whole pathology department to share their data and having a company work closely within headquarters was a game changer. On the other hand, because of disclosure of conflict of interest, it ended up being a lot more problematic than it was upside. And, I don't know what's behind Tom leaving MSK and going to Mount Sinai, but an interesting experiment's going to involve in the next chapter for Page AI. And I wish them well because they're really doing amazing things for the discipline. And then the third step, Anil, is educating leadership on the value of pathology in our health systems and our hospitals. We stay in our basements. We don't sit on financial decision-making boards. We're comfortable being a doctor to other doctors. And we have to raise up people in pathology to get more vocal about the value of what we do, both in the cancer center, in the medical school, and in academic health systems and with our hospital. And that is going to take a cultural change with our trainees to make that happen. So I've said some very controversial things. There's got to be some responses to that. So I'll welcome others to chime into the conversation.
Yeah. I think one of the comments was about your comment about the veterinary pathology and how closely, in terms of, impact that would be understandable. So actually, I have some of my colleagues in the audience from OSU. I don't know if they can chime in. Krista and Sue are online, I think. Maybe they can comment on the importance of veterinary pathology and its impact on digital pathology and what they've done at OSU. So Krista is on, I think Krista is online. And Krista is a former president of American College of Veterinary Pathologists. You're on mute, Krista.
Are we waiting for a comment?
Yeah, Krista is going to give a comment. She's on mute.
Can you hear me now?
Can we hear? We can hear you. Yeah.
Yeah, thank you for the shout out, Michael. There's a couple of veterinary pathologists on the line and everybody was pretty excited to hear that. We're pleased to be here at OSU and work with Anil and his group, all that they're doing. Our field is very much evolving quickly and trying to prepare our trainees for a future which involves this digital pathology and image analysis and working with large teams that include computer scientists. So I think the only way to move forward is for all of us to work together. And thank you again for doing that.
Yeah,
I think I'm going to let Raghu take over because I think we have other speakers coming up. So Raghu, you want to take over the...
Sure, I can take over. I also wanted to add that the person that Krista is mentioning, one of the folks, he's actually part of our team with Anil, myself, and David Liebner. Is fantastic. There is no other word. If he's online today, hopefully he's blushing, but he's just wonderful. so yeah, I mean, no, I completely agree with using the help of veterinary pathologists. Yes.